Hi, everyone. Thank you for joining. So, let me tell you a little bit about our talk. So, today we are going to talk about Kubernetes policy as a code for platform engineers. And we would try to make this session a little bit interactive because I know everyone had a very heavy, hefty, tasty lunch. So, considering that, let me kick off this session with my co speakers. Let me introduce Kamal.
Hello everyone, I'm Mohd Kamaal and I'm a contributor to Kyverno. And today we are going to get to know that how we can we can use policy as code with Kyverno.
Hey everyone, I am Kushal Agrawal, a platform and DevOps freelancer and also a former LFX mentee, and right now working with some YAML codes rather than my legs.
Thank you, Kushal and Kamal. So, hi once again. I am Sonali Srivastava. I am a developer advocate at InfraCloud Technologies. It's an improving company. At my work, my only task is to make technology accessible to everyone. Everyone can understand that. That's the only goal of mine. So, I write documentation, I do POCs, try to find out integrations that don't exist in the documentations, and then write about it. And yeah, definitely speak at conferences. Outside of work, so this is my full time job, okay? Outside of work, I have another full time job, and that's being a mother. And since I am a mother, my real world frame of reference is my home. So the slides that are going to come up, you will find that relation a lot. And that's why I'm going to ask you a very simple question, that how many of you are a parent here? A quick show of hand. Nice. Can you relate to this picture? Okay, now let me ask you one more question. How many of you are parent of a cluster? Okay, good show of hands. So you can, I think many of you would have already understood in which direction I am going. So let me first start with the real world example. So if a child gets access to a place in the house that is not supposed for them, you can understand this can happen. Now, what is this? The child gets access to the cupboards. The child gets access to your utensils. They can fall, they can crack. They get access to your appliances in the kitchen. They can run that on their own. You just imagine your child using the blender. And then they can also get access to the knife. Okay. Now let me bring this example to your cluster. Okay. Now how that happens? Suppose you have a team of ops. You have a team of in your team you have QA member. You have DevOps people. Now, if you give the access to everyone of your cluster, this may happen. I think many of you can already relate with the talks that have been happening. And all of us have been talking about ensuring and guard railing your clusters. So, this is what happens when you open the doors for everyone, for your entire team, unanimously to your production clusters. So everyone gets access to your resources, like your utensils in the kitchen. They get access to your tools, like the appliances. They get access to your knife. You know, I don't want to put that in production cluster terms, what that is, but you understand what will happen now. So if I talk about a child, what the child is capable of in the process, they can unintentionally harm themselves. They can also destroy something that you have cooked and kept it in the kitchen, okay? And they can knowingly also harm the kitchen. Like they can just go ahead and destroy something thinking, okay, I don't want to eat this. Okay, I want something new. So let me destroy this. So what will happen? The mother or the father will have to cook up something new. So that's what happens when you come in the real world. Sorry, my notes pages are stuck and I don't rely on slide notes. So, when we see this relatable example in the production cluster, we need to understand that in a kitchen, it's I can put a lock in the kitchen, right? That's one way of thinking that, okay, I will close the door of the kitchen, the child will not get access. But that's a temporary solution, right? I'm just killing a challenge at the moment, but I'm not addressing the problem in the longer run. Why? Because the child can grow up, figure out a way to climb on something and open the lock. So we are not implementing guardrails in a proper fashion over here. Similarly, they can get key to the kitchen. Suppose I have put a lock, they can get key to the kitchen. So we need to make sure that the resources that are there inside the kitchen, they are, in terms of child, are baby proofed. I store the appliances in a way that they are higher enough and not accessible. Now, from a developer or a QA perspective, if I do not want to give them the access of particular resource, enabling RBAC is not enough. You need more things. So we need to ensure that anything that is enforced on the cluster is scalable and consistent. So we'll see a quick example over here where I have deployed an application on a Minikube cluster. It's a microservice application that I have deployed. And you can see all the resources are up and running now. Now, what I do, I go ahead and see, okay, the application is up and running. This is just to demonstrate the kitchen or any product running on a cluster. Now, what I do is, I am suppose a QA, and I want to try out a few things. Like, usually everyone, I think, is aware that we do not give a QA team member access of a production cluster. At least we all know that, right? Now, this is known, but what is one step further that we need as policy, as code? Why do we need that even? The reason is, any person who has the access to the production cluster can go ahead and deploy an insecure pod just to debug a few things, which is, I think, we usually do when you have a microservice running, you do not have access to that. What you do, you go to a production cluster, you say, okay, let me spin up a pod and let me just debug a few things and then come out of it. But what are you doing in the process? You are opening a vulnerability door. Now, ideally what should have happened is, no one should have been authorized to do this. But since I opened the door and deployed that insecure pod just to run a few commands, what can I see on my production cluster now? Let's see. So you can see all the services that are running. Now, this is what something that you shouldn't have allowed any team member to get access to. All the processes that are currently you are seeing that are on the screen are running on host. Now, from a container, you shouldn't have given this access. How this happened? This happened because we gave privileged set as true in the security context. And any normal pod that I am configuring, I don't think a QA is going to be aware, and we shouldn't be expecting a QA member to be aware of this. Now, this is where, if I just go ahead, and since I have the access, suppose I am a hacker, I have an access of the cluster of this particular container, I kill the kubelet service. What will happen? A container that was just a mini pod, inside a pod, is now capable of bringing down the whole service. So that's what happens at your home when you give access to your kitchen to your child, that the food can get damaged. Similarly, your services can also go down. So, what we need over here? We need a solution for platform engineers, because for a team member to work in a team efficiently, we need to have consistent environment for everyone so that the drift is minimum. Now, if suppose new person is joining, a QA person is also joining, if they have to perform a test, they should not be worrying about, or a developer, if they want to deploy something and test out a few things, they should not be worried about, I am not adhering to some of the standards, so that they do not open such vulnerability doors which can damage the clusters itself. The drift that we have to make sure that the drift is minimum. So we need to implement policies as code. And once you implement, you get a platform which is scalable, secure, efficient, and ready for your developer, your team members to work efficiently. Once you have applied these policies as code on a cluster, you know that these are all automated. It's applied consistently across all the environments, like even if it is production testing. This is ensured that the QA team members does not have access to production cluster also. They do not have the access to those particular services. So the privileges are applied consistently across for a particular role. Similarly, the solution that we are trying to implement here, this will help in ensuring that the solution is scalable, and we are empowering the developers. They don't have to worry about they are opening the vulnerabilities. They are just focused on shipping a product on timely to the market. They will have a transparency. All the policies that they are trying to implement will be in a version controlled manner in a GitHub repository. So they will have transparency of the policies applied. It can be easily audited. And then the developers can not only build confidently, they will unintentionally also, they will be adhering to the security standards. And what the platform engineers are achieving in the process, they are accelerating the developer velocity. So with this, the platform engineers need policy as a code, but how to achieve that?
So answer is Kyverno. Kyverno is an open source incubating project, and Kyverno itself means to govern, and that what we want to govern. And policies are itself works as a Kubernetes resources, and with Kyverno you can automate resource and compliance. Well, how Kyverno works? It's just YAML, no custom servers, and you don't need to learn any kind of language to write policies. So it runs as a dynamic admission controller, and Kushal will tell you about admission controllers.
So now you have your answer. Who can save the platform engineer? So what exactly is admission controller? Think of it as a Kubernetes bouncer. You send a perfectly crafted YAML, and Kubernetes say, hold up, let me see, this follows the rule. It hits after authentication and before services saved in the cluster. So even if you are allowed to create something, the admission controller can still set up and say, sorry, your pod needs label, or even say, but nice try, but not in my cluster. Admission controller can modify your request. Those are called mutating webhooks, or just validated. Those are validating ones. And sometimes they do both. Tools like Kyverno are built on this architecture. They act as a dynamic admission controller, letting you define custom policies the Kubernetes will enforce in real time. Pretty cool, right? All right. So why you choose Kyverno?
Why Kyverno? Because it's powerful and it makes policies approachable. But Kubernetes already have native policies. So why Kyverno? Let's talk about the Kubernetes native policies. It has validating admission policy and mutating policy, and they are using cell or common expression language which offers predictable performance and works well for both simple and moderately complex validation logic. But it has its own limitation. So native policies works for admission only. What if you want to apply the policies to the existing resources? Then it won't be that much useful. So it cannot do multi-resource checks. It cannot be or now I'll talk about the Kyverno features. Well, with Kyverno you get built-in features like exceptions. You get policy reports. You get auto generation for the auto generation policies for the controllers, and we have dedicated testing tools like Chenso for end-to-end testing, and we got kubectl Kyverno CLI for simulate policy, and so you can test them in your, you can write them in your CI/CD workflow. Here's a detailed comparison with validating admission policy. As you can see, enforcement on admission, but validating policy gives you admission, background, and pipeline. Well, it's not with a validating policy you can enforce policy on Kubernetes resources, but it is not limited to it. You can it can work on any JSON payload inside or outside of Kubernetes. Validating admission policy has basic cell library, but validating admission policy has basic cell library, but with validating policy you get extended Kyverno cell libraries which can be used for customized policy validation. We've got, as I told, we have reportings and testing. But I would like to talk about Genso and what if, like, take a scenario, what if we want to test some Kubernetes resources and we have to do manual tasks, but what if I want to automate those tasks to test some resources in Kubernetes? Well, this is where Genso comes, and Sonali will tell you about it.
So with chainsaw, so chainsaw was initially used, I think, internally, and then then Kyverno decided to let it be there for everyone to use. And the power of chainsaw is, before implementing the policies, you can actually test it out, that whether it is going to behave, the policies are going to behave in the intended manner or not. So this is an example of how Kyverno works, where any policy that we are going to apply, once the policy exists on the cluster, any incoming resource request or update or create, how Kyverno behaves, Kushal will explain you.
All right, so how does Kyverno actually work? Imagine Kubernetes is about to let a pod sneak in, and in your cluster, just before it opens the gate, it's call up Kyverno and say, hey Kyverno, does this YAML looks good to you? Kyverno acting like that overprotective girlfriend and checks all the policies you have written, stuff like privileged containers, add labels, or don't let tab go build with CPUs. If pod behaves, Kyverno notes and lets it in. If not, Kyverno rejects straight up. It does this using something called dynamic admission controller. Fancy term, right? But it means it intercepts requests in real time before they are saved in a cluster. Now behind the scene, these are the whole crew. A webhook server catching the request, a background controller fixing things quietly later, and a report team filling complaints like the pod is sketchy. And don't worry, it scales too. So even if your cluster gets wild, Kyverno keeps up judging every YAML like it's paid for it.
Cool. That's actually very cool. So now that we understand how Kyverno helps platform engineers, how it focuses on accelerating the developer velocity, we need to understand some of the use cases, and I hope you get a good takeaway from it and go ahead and implement that on your clusters. So we'll take the first, we'll tell you what came with Kyverno 1.15, which was recently released. So with Kyverno 1.15, like Kushal and Kamal told you, that Kubernetes moved to validating admission, VAP and MAP. Now Kyverno also launched these new policy types where you already have your current policies, the cluster policy which used to work. Suppose if you have a single policy, you can have multiple rules within it. A validate rule which will check, suppose for a label whether it exists or not. A mutate rule which would append a label probably. A generate rule which would create some resources depending upon some resource that is getting created. So we already had a very strong foundation, but then we thought of building on top of it. And that's where these new policy types came in, a very dedicated solution to each type of requirement. Now, how they help is, we are going to cover with these use cases. We'll jump on to the use cases directly. But before that, we would like to tell you that in this GitHub repository, we have placed all the use cases that are there. And for that, you will need Kyverno up and running on any Kubernetes cluster. You will need Kyverno CLI installed. And probably we missed one more thing here, chainsaw also configured. Okay. So this is the first example. And This was yours. Sorry. So Kamal will explain you this. Yeah.
So with Kyverno, we can do this policy. Let's talk about this policy. So this policy, what it does is it helps you write best practices and automate the things like adding labels for any pod created in your cluster or any defaults value you want whenever a resource is created. So we have mutating policy. We see it's in alpha. So what it does is it is adding label. We have a target to pod. Whenever the pod is created, it will do what will do it is it will add the label to it using cell expression. Yeah, the patch type is of apply configuration, but it can do for the JSON too, and you can try it and or read about it on Kyverno documentation. Over to you, Kushal.
Now we have a resource optimization, configuration, and governance example. It's like a boon for every platform engineers, and as a platform engineer freelancer, I know how it's much hectic. So in this example, we enforce every pod when we created or updated have a memory limit, CPU limits. So our Kubernetes cluster never down, because I don't want to answer every time my clients why my Kubernetes cluster is down due to some intern and everyone. Now, what's your point about this, Sonali, as a mother?
So you don't want your resources to be exhausted, right? So if you do not focus, if, as a platform engineer, if I do not focus on limiting the resources or optimizing the resource utilization on a cluster, I will not get a mail which says we are scaling down the clusters because it is exceeding the cloud bill. I'll probably get a mail we are scaling down the platform engineer. So, to avoid such scenarios, I think platform engineers can benefit a lot from such policies in place where they are limiting the resource utilization. Also, when once a developer has built an image, it's not their task to ensure that it is being fetched from a right location, right? Or suppose the DevOps engineer or the platform teams have already ensured that the image is signed, there are proper attesters like cosign in place, and they are doing the image validation. Along with that, you need something more which Kyverno is actually providing over here with this image validating policy. In this policy, we have made sure that any insecure registry is not allowed, and then the providers that I want as a platform engineer, those are only authenticated using the secrets that are mine, and then only these providers will be able to authenticate and allow the fetching of the images. So such type of policy will not only help you with the security at a smaller level, they will help you ensure the supply chain security also. Moving on to our final use case, which enables the self-service, Kushal is going to explain you this.
All right, let's look at this next policy. It's not about the code, pods, or containers this time. It's about Terraform plan. Yup, your Kyverno can validate those too. Pretty cool, right? So here in this setup, someone pushes a Terraform plan that's going to create an EKS cluster. And we want to make sure the cluster public endpoint access is turned off. Because let's honest, leaving your Kubernetes API open to the internet is like duct taping your house key to your front door and saying security or why obscurity. Let's walk through this YAML. We are using this JSON format, and in the match conditions, we have two conditions. First, we check the whenever anyone hits Terraform plan, then, and the second condition is whenever anyone create a EKS cluster. So Kyverno is like cool, Terraform focus found EKS cluster detected. Let's go. Now comes the validation section. This was the Kyverno gets strict. The rule says in each module for every EKS cluster, check if public access is enabled and if it deny. So unless the Kubernetes cluster is stuck safely into a VPC with public access turned off, this policy throws the Terraform plan out of the window. And honestly, that's a good thing because debugging why is my Kubernetes cluster being scanned by the internet every 5 minutes is not a fun Tuesday. So with this policy, Kyverno step in during CI, reads the Terraform JSON plan, snips out insecure EKS configuration, and sleeps a big one on them before they go live.
So I think we were able to let you know for the new policy types, the platform engineers, it's not the solution Kyverno, it's not dedicated only to Kubernetes. It's going beyond Kubernetes and making sure that any JSON that you are bringing in, it's validated, the policies are getting implemented to it. But what about our existing user? We cannot forget about you. You are our favorites. The new ones are also, but you are our favorite. And we would motivate you to plan to migrate to cell expressions because it's being now followed by Kubernetes also. And it's very easy to write. And the new policy types, documentations are already being updated. So we will showcase you one example. There are more in the repository, where we will show you how you can migrate an existing policy that you have already on the cluster. You can change the new policy type using some of the methods that we are going to show you. Kamal will help you with that.
Well, before the migration, let's talk about, or I can tell you about the use cases. Use case between API call versus now Kyverno's cell library. So with API call, you can fetch Kubernetes resources, and with API call you could call external HTTP APIs. But API call is manually defined and it injected to context, and you need to access the variable using James path. So what in the new policy type we are doing is these fields are migrated to cell functions. So resource.get and resource.list is like getting or fetching the resource locally, and http.get http post is for external APIs or subject and subject access reviews. So no need to manually define a context block because we've got cell functions and we have variables. So you're not going to miss out on any kind of predefined context variable. They are migrated to cell functions, image data, pass service account, and global context. So I'm going to showcase a demo about policy to generate config map on namespace creation. Okay.
You explain. So here in this scenario, we are going to showcase you one example where suppose you have a cluster policy already in place. We are not going to explain or drill down on what this policy is doing. We are just trying to compare. Suppose you had this policy. Okay. Suppose you already had this policy on the cluster up and running. You are already aware with Kyverno. And then what all changes we have made over here is we have migrated some of the fields, you can say, and the way we are writing it. So you can see we already had a feature of passing the operation that we need to perform for a particular kind that we are filtering. We are now able to pass it as a constraint. And then going ahead, if I suppose have set a context, I can pass that directly using the cell expressions. And suppose I have defined a use case where I want to generate a particular config map, you can see how easily you can pass an expression like this. So in that, it is all, and then what we have done is we have actually optimized this implementation. So cell expressions give you this power that you can also optimize the policies and then ensure that they are consistently applied. So not only this is benefiting, but also it is making the task of a platform engineer very easy. So when you are migrating, you can definitely reach out to to the Kyverno team and they have a very active Slack channel. So we can help you with the migration also. I think Kamal has a server up and running where we can show you a chainsaw test. The Kyverno is already running over there, and we'll show you a chainsaw test which can implement this policy.
We got a cluster policy.
We'll apply the we'll do the chainsaw test. Clear. Just zoom out a bit. Close that side. Close that side one. It's visible. We hope the screen is visible. Explain it. So in the chainsaw test, you can see how using this chainsaw test, we wrote a couple of, so the test is also written in YAML. We were able to execute and generate a result from which you can understand how the policy is going to behave on the cluster itself. So if you see it is performing create policy, it is performing create namespace, check the config map is generated and then perform a cleanup. So this is how you can actually manage and migrate very easily and do it in a way that is very healthy for everyone. Not only you are focusing on empowering your developers, we are also empowering the platform engineers. Because in today's scenario, what matters is the experience. And it's not the experience, is not about the user. I think in one of the keynotes, I think Atul mentioned this, that it's not about just the user experience. Now the developer experience or any engineer experience matters. So products or tools like Kyverno are trying to make the life easier of everyone who is using products. Going back to our slides. Are we there? Okay, sorry. So what is on our roadmap? On our roadmap, we plan to move to new policy. We plan to move the new policy types to beta. What I mean to say is, I think you must have seen on our policies, we wrote alpha at the top. That's because currently they are in the alpha version. We'll soon be moving it to beta. We also want to have namespace cell policies. We want to have fine-grained cell exceptions. If you want to know more about this, we have every Wednesday and Tuesday the Kyverno meetings, and you can join them. Then how you can contribute to Kyverno? I have contributed to Kyverno's documentation, but these folks have contributed to the code base of it via LFX mentorship. So there are many ways you can scan this QR code and get access to the repository. You can also join the Slack channel. And that's all. If you have any questions, we are sorry we took 5 minutes extra.